Welcome to Unit 4, Lesson 5, Say It with Decimals. We're going to start today with a warm-up. It's another notice and wonder, fractions to decimals. So a calculator gives the following decimal representations for unit fractions. I want you to note what do you notice and what do you wonder. And I'm just going to split this into two pieces for myself. So write down what do you notice, what do you wonder, pause the video and come back. All right, welcome back. So I'm just going to note a couple of things that some students have noticed before. So different fractions have different numbers of digits is one. Something else you could have noticed was some decimals repeat. So we have like 3, 3, 3, 3, 3, so on and so forth. And then we have the 1, 6, 6, 6, 6, 6, 6, 6, and then it's 7 to stop the repetition. Some decimals don't repeat. So like 1/2 is written as 0.5, 1/5 is 0.2, 1/4 is 0.25. Some decimals almost repeat except for the last digit. So 0.0909091, the last digit is different and it ends that cycle. Some things that you wonder could have been, do some decimals really finish after 7 digits or do they keep going? Why are some decimals shorter than others? Or are there any fractions that only have 1 digit after the decimal? So if you haven't guessed now by the title of this lesson, we're going to do some decimal work today, converting from fractions to decimals. We've done this before in the past, but today we're going to really focus in, and I want you to try your best. So try some of these problems before you move on to the next section. So in looking at number 1, this is a section I would like you to try on your own. So use long division to express each fraction as a decimal. So we have 9/25ths, 11/30ths, and 4/11ths. I want you to pause the video and try to divide these on your own. All right, welcome back. So what we're going to do is we're going to divide these numbers. So on the inside, you're going to have 9 and 25 on the outside because 9 is being divided by 25. 25 can't possibly fit into 9, so we're going to put a decimal and add a 0. Now we can figure out 25 goes into 90 how many times? Well, if we think of quarters, we know 3/4 is 75 cents. And if we add a 4th quarter, we'll end up at 100. So I'm going to say 3, and we can put down 75. Subtract that. This becomes an 8, 10, 5, 15. If we add a 0, we have 150. So 25 goes into 150 how many times? It's going to go in 6 times. So if we have 6 quarters, we would have $1.50. In this case, 6 times 25 is 150. All right, let's check the next one, 11/30ths. So on the outside, we're going to have 30, and on the inside, we're going to have 11. We're going to have to add a decimal because 30 isn't going to fit into 11, and add a 0. How many times might 30 fit into 110? So 30 can fit into 110 3 times. And that will give us 90. When we subtract, we will be left with 11 minus 9 will give us 2, and we're going to have to bring down another 0. So now we've got to figure out 30 goes into 200 how many times? Well, we can think about 30 goes into 20. It goes in 3, 6, 9, 12, 15, 18. So it goes in 6 times. And we're going to end up with 18, or in this case, 180. And we're going to subtract and be left over with 20. And it looks like this is going to keep repeating. We can tell just from here that this is going to repeat over and over again of 0.6, because it's always going to be 30 goes in 6 times 180. So this one we would write as 0.36 repeating. This little line above this means repeating. Now let's look at 4 11ths. So our 4 goes on the inside, 11 on the outside. Again, we're going to have to add a 0 because 11 is not going to fit into 4. But 11 will fit into 40. And it'll fit into 40 3 times. We'll have 33. Subtract 7 left over, add a 0. 11 goes into 70 6 times. We'll have 66. Subtract, left with 4. Bring down another 0. 11 goes into 40. It's going to go in 3 times, and we're going to end up with 33. Oh, this looks like a different type of repeating pattern. So it's not just the 1 digit that repeats, but it looks like it's going to be the 2 digits. So this one's going to be 3 6 repeating, because it's going to keep going back and forth between 70 and 40, 70 and 40. So we can write this as 0.36 repeating. So the 3 and 6 are going to repeat over and over and over and over again. All right, let's turn the page to 274. And we're going to go to the top of it. It's going to be number 2. And I want you to write on number 2, what is similar about your answers to the previous question, and what is different? So I want you to write, what do you notice is similar, and what do you notice are different? All right, welcome back. So something that you could have noticed was similar or different. We'll start with similar, and we're looking at these. You might have noticed this is 3 and 6, 3 and 6. So each time it has the numbers 3 and 6 in it. Now, what could have been notice that what you could have noticed that could have been different is that 9/25 is the only one that doesn't have a repeating decimal. It had an end. It had a stop to it. Whereas the other ones had a repetition that would keep going and going and going. So 9/5 decimal representation is different than 11/30 and 4/11. So 4/11 and 9/30? 4/11/30 had repeating decimals. Whereas 9/25 did not. So number 3 now wants us to use the decimal representations to decide which one of these fractions has the greatest value. So that's a little bit of a tricky question. Which one has the greatest value? But if we write it like this, so 9/25 was just 0.36. And then we had 11/30, which was 0.36666. It would have just kept repeating. And 4/11 was 0.363636. So out of all of these, which ones do you think has the greater value? So if we look here, this one stops after the hundredths place. So we don't have anything extra once it stops here. There's nothing, no bigger pieces to it. But these ones have bigger pieces. So we're going to have to look at the thousandths place to find the one that has the bigger piece. And in this case, 6 is bigger than 3. So 11/30 would have more pieces to it than the 3, 6 repeating. So 11/30 would be the largest, would have the greatest value. And it would have the greatest value because we have 6 in the thousandths place. Is in the thousandths. And that gives it the bigger piece. Okay, what we're going to move on to now is we're going to move on to page 275. And it says match each diagram with a description and an equation. So we want to match it with a description and an equation. So the descriptions are an increase by 1/4, an increase by 1/3, an increase by 2/3, and a decrease by 1/3, or a decrease by 1/4. We have our equations: y equals 1.6 repeating x, y equals 1.3 repeating x, y equals 0.75x, y equals 0.4x, y equals 1.25x. So we've got to figure out diagram A. Which one would that match with? So if our x has 4 pieces and our y only has 3, which one of these would show us an increase or a decrease that would represent this? So if y has 3 pieces and x has 4, we have 4 pieces. So is this one being increased or decreased? So I think we could say this one is being decreased by 1/4. And I say that because this is one less piece than the rest. So we have 3/4 instead of 1/4. So now we've got to figure out which equation matches up with this. So which one of these shows us a decrease by 1/4? So if we're decreasing by 1/4, we're left with 3/4, and I need an equation that shows me 3/4. So I might want to write 3/4 as a decimal because these are all decimals. So I could go up here. I would put my 4 on the outside, my 3 on the inside. I'm going to have to add a 0. 4 goes into 30. 8 times is 32, so we would probably say 7 times, which is 28. Subtract, we're left with 2 left over. 4 goes into 25 times. So we're going to want the one that's 0.75, and we have that right here. So this one's going to be y equals 0.75x. Now let's go to B. So B, we have 1, 2, 3, 4 pieces that start with x. So this will count as our whole like we did before. So pieces that start with x. And then our y has 1, 2, 3, 4, 5 pieces. So this one looks like it would be more on the increase end. And what do we think it's being increased by? So we have 4/4 here for x. How many fourths are we adding? Yeah, we added 1/4. So we're going to be increasing by 1/4. So if we're increasing by 1/4, we want to count how many fourths do we have here? We have 1, 2, 3, 4, 5 fourths. So we need to figure out what's the decimal representation of 5/4. So we're going to go over here and we're going to divide 5/4. So 4 goes on the outside, 5 on the inside. 4 can fit into 5 in this situation, and it fits in once. So we subtract, we have 1. 4 goes into 10 2 times. We have 8, we're left with 2 left over. 4 goes into 20 5 times. So we're going to want the one that's 1.25. So we'll find our equation right here, and it's going to be y equals 1.25 times x, because it gives us that extra fourth. So now it wants us to draw a diagram for one of the unmatched equations. So you're going to choose one of these unmatched equations and go ahead and draw a diagram for it. Pause the video and then come back. All right, so Miss Bailey is going to choose to do this one here, y equals 1.3 repeating. So I'm going to start by drawing my diagram. And I want it to have 4 pieces, but I only want to have 3 of them colored in. So I'm going to color in 3 of them to represent my x. And then my y is going to have this extra third because this is 1/3 larger. So this is what my diagram would look like. It would be 1/3 larger than the x. All right, the last part of lesson 5 is a card sort. Because you are watching this video lesson, I want you to print this out at home and work with it with, instead of a partner, you could do a parent, a sibling, or somebody that is in your home or working with you, and match these up and see how many matches can you get. I'll see you next time. Bye.